Indrani, this class is for class 9th. You don't have maths class today, Indrani. Good evening. Good evening. Good evening. Yeah, children, there is a problem on the board. See, ABCD is a cyclic quadrilateral in which AB equal to BC, angle DBC 70 degrees, BAC 30 degrees, and you need to find out X value and Y value. X is nothing but BCD, angle BCD means total angle. This total angle you need to find out, that is BCD, and ECD means only this angle you have to find out. Okay, now in the figure we can observe an isosceles triangle. In the figure we can observe an isosceles triangle. What is that? Can anyone say? ABC, very good. ABC is an isosceles triangle with AB equal to BC. Okay. In triangle ABC, AB equal to BC, which implies angle BAC is equal to angle BC. Angle BAC equal to angle BCA. That is, angle BCA is 30 degrees. Means this one is 30 degrees. Now, can we find out the measure of this angle, children? In triangle ABC, can we measure that? Is it possible to measure this angle, to find this angle in triangle ABC? This one. How much it will be? Sum of all interior angles of triangle. Yes. In triangle ABC, 30 degrees plus 30 degrees plus 70 degrees plus angle ABD. This angle is ABD, is 180. ABD is 180. Means 30 plus 30 plus 70 plus this angle. This angle is nothing but angle ABD, 180 degrees. So 60 plus 130 plus ABD is 180. 80. So angle ABD is equal to 50 degrees. This one is 50. Very good. Now, yeah. Now, observe angle ABD and angle ACD. Can I say they are equal? Angle ABD, ABD, ACD. Are they equal, children? If they are equal, you need to tell me the reason. Angle ABD, ACD. You feel they are equal? What is the reason? If you feel angle ABD and angle ACD are equal, just I want to know the reason behind it. No one talking? Hemachandra, what is the reason angle ABD and ACD? Why angle ABD and ACD are equal? No one. Aniket says yes. Now he is saying we need to find x and y. Good. And I am saying angle ACD is nothing but x. ACD is nothing but y, na? ACD is nothing but y. I am saying angle ABD and ACD are equal. Just I want to know the reason from your side. Angle ABD and angle ACD are angles in the same segment, are angles subtended by the same chord AD at C and at B. Angles subtended by same chord AD at B and at C. Angle ABD equal to angle ACD. The reason is angles in the same segment are equal. Angles in the same segment are equal. So, angle ACD, that is Y, is 50 degrees. Okay, na? Now x is equal to this is we got 50 degrees, na? 50 degrees plus 30 degrees, 80 degrees. X is equal to 80 degrees. That is BCD. Angle BCD is 80 degrees. Okay, na? Once again, children, from triangle ABC is an isosceles triangle. ABC is an isosceles triangle with AB equal to BC. So this angle is 30, this angle is also 30. Now in triangle ABC, sum of interior angles is 180. So 30 plus 30 plus 70 plus this angle is 180. Then this angle is 50 degrees. Now angle ABD, angle ACD are angles in the same segment. They are the angles in the same segment. They are equal. So angle ABD 50 degrees, so angle ACD is also 50. Now we need to find x value also. We got y value 50 and we need to find x also. So x will be 50 plus 30, 80 degrees. Okay, right? Next question. If the diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, prove that it is a rectangle. There is a circle and there is a cyclic quadrilateral. Okay, AB, CD, and this is the center of the circle. Okay. Now the diagonals of the quadrilateral passes through center of the circle. We need to prove ABCD is a rectangle. ABCD is a rectangle. Okay. Yeah. When a quadrilateral becomes a rectangle, children, ABCD is a quadrilateral here. What was the way to prove that a quadrilateral becomes a rectangle? How can we prove? Or what is enough to prove? What is enough to prove that ABCD is a quadrilateral? ABCD is a rectangle. When all its angles are equal to 90 degrees. Yes. So we need to prove angle A 90, angle B 90, angle C 90 and angle D is also 90. Right. Good. Given ABCD is cyclic, required to prove and AC and BD are diameters. AC and BD are diameters. Required to prove ABCD is a rectangle. That is angle A, angle B, angle C, angle D are all equal to 90 degrees. If we prove all the angles of quadrilateral are 90 degrees, okay, then the problem is done. Then it becomes a rectangle. Now, how to do it? How to prove? Any idea? Children, to solve this problem, you have to keep these 2 points in the mind. Given AC and BD are diameters. AC and BD are diameters. That is what you have to keep in mind. Any idea? What we have property basing on diameter? What we have, then you are going to Aniket, you are going to Venkateswara classes, na? Why you are not getting ideas? Many people are going to Venkateswara classes. Not only Venkateswara, Fiji, అలాగే అనుకోండి ఏంటది అంతే దాని ఏంటది వాట్ ఈస్ ద క్లాస్ ఆకాష్ ఎస్ ఆకాష్ ఫిడ్జీ వెంకటేశ్వర క్లాసెస్ యూ ఆర్ గోయింగ్ what is the property that we have basing on diameter? We know diameter divides the circle into two equal parts and each part is called a semicircle. Morning only we have discussed about that one, or yesterday's class, even yesterday's class also we have discussed. Okay, consider diagonal BD. Consider diagonal BD. BOD diameter, na? And what is this angle? What we call this angle? BOD diameter, and what we call angle BCD or angle C. What we call it as? Yes, right angle. Good. Angles in the semicircle. Angle in the semicircle 90 degrees. That was the reason. Angle BCD is 90. Reason? Angle in the semicircle. Angle in the semicircle is 90. So this is 90. Okay? Now, AOC, here BD diameter. Now, consider AOC, diameter AOC, diameter AOC, angle ABC is 90 for the same reason. AOC diameter given, na? Then this angle is also 90, angle in the semicircle. BOD diameter, then this angle in the semicircle 90. Even this one is also 90. Angle in the semicircle, same reason. Angle in the semicircle is 90. This is 90 and this one is also 90. AOC is the diameter. So angle ABC 90, ADC 90. Angles in the semicircle. This angle is in this part semicircle and this one is in this semicircle. So now each angle is 90 only. All the four angles of quadrilateral ABCD is 90, 90, 90, 90. So we can call it as a rectangle. Or you can also do this problem like this. BOD diameter, BCD angle in the semicircle 90 degrees. If this is 90 and this is a cyclic quadrilateral, sum of opposite angles of cyclic quadrilateral is 180. So if this is 90, opposite angle is 90 because sum of these two must be 180. and AOC diameter, ABC angle in the semicircle. This is 90, and the opposite of this angle is also 90 because sum of these two angles must be 180 since it is a cyclic quadrilateral. Okay na? Only Aniket and that another girl, she is only repeating or giving the answers. And the remaining, whether I don't know whether they are listening to it or not, I don't know. Sumukha Santoshi. Only these two are responding. Even Sohili also not. Yes sir, yes sir. Yes sir ante yes sir ante. Now question number 8. If non-parallel sides of trapezium are equal, prove that it is cyclic. ABCD is a trapezium. ABCD is a trapezium. These two sides are parallel, and these two are non-parallel sides. Given they are equal, AB and given ABCD is a trapezium. Where AB parallel to DC. Not only that, AD is equal to BC. This is given. And what we have to prove? Required to prove. What is required to prove? ABCD is cyclic. That is angle A plus angle C 180. We have to prove that. If sum of opposite angles is 180, then that quadrilateral is cyclic. Okay na? Now how to prove this? We need to prove ABCD is cyclic. And what is given? ABCD is a trapezium, AB parallel to DC and AD equal to BC. In order to prove ABCD is cyclic, it is enough to prove angle A plus angle C is 180. Now, proof. There is a problem in quadrilaterals topic. In an isosceles trapezium, base angles are equal. In an isosceles trapezium, the base angles are equal as well as top angles also equal. There is a property. In an isosceles trapezium, angle A is equal to angle B. It was proved in the quadrilaterals topic. Angle A is equal to angle B. But angle B plus angle C is 180 degrees. Angle B plus angle C, sum of these two angles is 180. Can anyone say what is the reason for it? Why angle A and angle B are equal? It is there in quadrilaterals topic, you can go through it. I can give you the proof also here. Draw DM perpendicular to AB, CN perpendicular to BAB. Okay. Now we got two triangles over here. In these two triangles, AD is equal to BC given. Angle M90, angle N90 by construction. And the perpendicular distance between parallel lines is same everywhere. I told you, and I am saying this one, railway tracks. These two are like sleepers, means the wooden blocks in the middle of the tracks. It is same everywhere. So these two are equal, and 90 degrees. So the two triangles are congruent. Triangle ADM and BCN are congruent. By which congruency? They are congruent. What is the congruency criteria used? SAS. Sumuka, is it SAS? Bhashita also says SAS. ASA, Meghana. RHS congruency. RHS congruency, hypotenuse, right angle, and a side. By RHS congruency, triangle ADM congruent to BCN. CPCD, angle A is equal to angle B. So in that way, angle A is equal to angle B. Now, angle B plus angle C 180 I am saying. Why? What is the reason? Angle B plus angle C 180. Is that right or wrong? Is that statement right or wrong? Angle B plus angle C is equal to 180. Is that statement right or wrong? What we call angle B and angle C? What we call angle B and angle C then? What we call them? What type of angles are there? Alternate angles are, corresponding angles are, vertically opposite angles are, adjacent angles are. So adjacent angles, a quadrilateral, any quadrilateral, can we say sum of adjacent angles is 180 in any quadrilateral? Oh. Bhashita? So in a trapezium, sum of adjacent angles is 180. Is that right? Then you are saying yes. Everyone is saying yes. Now you are saying no. Now everyone say no. what I am asking, in a trapezium or in a isosceles trapezium, sum of any two adjacent angles is 180. Is that right? Sohail is out of syllabus, eh? Sohail, you are out of syllabus. Aipayo. Spoiled. No answers from your side. That is what? Out of syllabus means you are not able to recollect the concepts. That is what we call out of syllabus. So everyone in your class is like this. So long ago, maybe one month ago or 1.5 months ago, on this point only I quit the class for 2-3 days. What we call, these two lines are parallel. These two lines are parallel. This is the transversal. And what we call these two angles, right? Are you sleeping now? Aniket, are you sleeping? Angles on the same side of the transversal. Interior angles on the same side of the transversal. They are supplementary or co-interior angles. Who said this? Who said this? Who said this property? Interior angles on the same side of the transversal, supplementary. Who said this? And what we call that property? That property is having a special name. Euclid. Euclid fifth postulate. I told you that whole geometry depends upon Euclid fifth postulate. It depends upon the fifth postulate. But you are not you are not able to recall it. You need to write the reason here why angle B plus angle C is 180. Now my question is there any other pair whose sum is 180 here in this figure? Is there any other pair of angles? Is there any other pair of angles whose sum is 180 here? Other than angle B plus angle C 180, na? Angle B plus angle C 180. Euclid's fifth postulate. Yeah, angle A plus angle D is also 180. Now, see here, I am replacing angle B with angle A. See, I am replacing angle B with angle A because they are equal. Both are equal. Angle A plus angle C is 180. So, since the sum of opposite angles is 180, the quadrilateral is cyclic. Since sum of opposite angles is 180, I am replacing angle B with angle A. Replacing angle B with angle A because both are equal. Angle A plus angle C is 180 because A and B are equal. So, since sum of opposite angles is 180, ABCD is cyclic. ABCD is a cyclic quadrilateral. Okay, na? Okay, you can leave now.